Alright, so this is the last video for this chapter 14. We're going to look at capacity and density. So the capacity of a container is the quantity of fluid it is capable of holding. Capacity units, 1,000 milliliters equals 1 liter. And 1,000 liters equals 1 kiloliter. It's very similar to anything else that we do with millimeters, centimeters, those kinds of things. So if we're asked to convert 3.7 liters into milliliters, we're just simply going to take the 3.7 and liters to milliliters, we multiply by 1,000. Or we move our decimal place 3 places, so we end up with 3,700 milliliters. And then 57,620 liters into kiloliters. We're going from liters to kiloliters. We're dividing, and we're dividing by 1,000. So it would be 57,620. And then we're dividing by 1,000, or we're moving our decimal place 3 places to the left. So we end up with 57.62 kiloliters. Volume to capacity. When we're trying to change things from volume to capacity, 1 cubic centimeter is the same as 1 milliliter. 1,000 cubic centimeters is the same as 1 liter. 1 cubic meter is 1 kiloliter. And 1 cubic meter is also 1,000 liters because 1 kiloliter is equal to 1,000 liters. So this is what we're going to use to change volume to capacity. So the first thing we have to do is find the volume of a three-dimensional shape, and then we can convert that volume to capacity. So pretty much it's just an extension of what we've been doing, finding volume. So it asks us to convert 9.6 liters into cubic centimeters. So we're converting capacity into a volume. This is a capacity, this is a volume. And then here we're going the same way from capacity to volume. So the way that works is we're going to multiply by 1,000. So we're going to multiply the 9.6 liters times 1,000. And that gives us cubic centimeters. So we end up with 9,600 cubic centimeters. And this number right here comes straight off of that chart on the previous page. Then 3,240 liters to cubic meters, we're going to divide by 1,000. Again, it comes straight from the chart on the previous slide. So we end up with 3.24 cubic meters, or meters cubed. Then it says find out how many kiloliters of water it takes to fill a 2.6 meter by 3.1 meter by 1.5 meter tank. So this is a rectangular prism. So first thing we need to do is find volume, and we find volume by doing length times width times height. So 2.6 times 3.1 times 1.45, and we get 11.687, and it's meters cubed. So now we have to take that volume and convert it into capacity. And to do that, we simply realize that 1 meter cubed is the same as 1 kiloliter. So all we have to do here is essentially change the units. So 11.67 kiloliters or 11.687 kiloliters, because these two units are the same. One's just volume and one's capacity. Then it says 17.3 millimeters of rain falls on a flat rectangular shed roof of length 10 meters and width 6.5 meters. All of the water goes into a cylindrical tank with base diameter 4 meters. By how many millimeters does the water level in the tank rise? So the first thing we need to do is look at the dimensions of the roof on the rectangular shed. So the 17.3 millimeters, we need to convert that to to meters because everything else is in meters. So the 17.3 millimeters, because everything else is in meters, we need to convert that to meters as well. So we're going to divide by 1,000, and we get 0.0173 meters. So the volume of water collected by the roof is the area of the roof times the depth. So, or the area of the rectangle times the height. So length, the area is going to be 10, or volume is going to be 10 times 6.5, and then times the height that we found, 0.0173, or the depth in meters, and that's going to give us meters cubed, or 1.245, and that's meters cubed. So we converted the depth here to meters and then used our length, width, and height to find the volume. So the volume is 1.1245. So that's for the roof. Then for the tank, we're going to do, the volume is the area of the circle times the height. So it tells us that the diameter is 2 meters. So an area of a circle is pi times, not the diameter, but the radius, which would be 2, and then squared. And then we have to take and multiply that by the height of the cylindrical tank, which we don't know. So then pi times 2 squared is going to be approximately 12.566 times the height. And that's again in meters cubed. So the volume added to the tank has to match the volume which falls on the roof. So this is the volume in the tank, 12.566 H. And the volume in the roof is 1.1245. And these two have to match. So we're basically just going to divide this by 12.566, divide this by 12.566, and that gives us a height of 0.0895 meters. So that is how much the water rises. Density. The mass of an object is the amount of matter it contains. 1 gram is the mass of 1 cubic centimeter of pure water at 4 degrees Celsius. So the mass of an object is the amount of matter it contains. The density of a substance is the mass per unit volume. So that's the mass over volume. That's how we find it. Mass divided by volume. Here are some common densities: pine wood, paper, water, steel, lead. So here's 2 other ways we can rearrange the formula. We can make mass equal density times volume, and we can make volume equals mass divided by density. So those are the 3 ways that our density equation can be worked out. So here's an example. It says find the density of a metal with mass 25 grams and volume 4 centimeters cubed. So we said the density equals mass divided by volume. So our mass is 25 grams. Our volume is 4 centimeters cubed. So 25 divided by 4 gives us 6.25. And then our units are grams per centimeter cubed. That's the end of this video.